Hello everyone. In this video, we are going to look at associative memory. So in a regular random access memory, all memory access is via the address. So given a memory with locations like this, and say these are the addresses, 1000, 1001, and so on, okay? So any access that we want to make to a memory is given an address. We will search, go to that particular address, and then find the word in it. However, sometimes it may be more efficient in order to improve our search. It may be important that we search not by the address, but based on the content. So when we search based on content instead of address, then the kind of memory that we use is called your associative memory. So in associative memory, we have the block diagram will look something like this. So first of all, you have an array of words. This is the memory, okay? And you have two registers. First one is called the key register. And then we have another register, which is known as the argument register. Argument register. So the key register will call it as K, and the argument register will call it as A. So in this associative memory, let us assume that there are, we have here M words or M locations, and each word is, so you have M words here, and each word is of N bits. Each word is of N bits. So this is your associative memory. Along with that, we have one more register here, which we have drawn like this, and this is called the match register. Match register. And we term this, use the term M here. So how are these different registers and this memory used? Let us look at that. So first of all, what we are going to do in case of associative memory is we are going to search based on the content. So instead of given an address, we look at the content and see if it is there or not. We directly match parallelly across all memory words, and we see if the content is present or not. So definitely it is going to be much faster as compared to your random access, because as we know, in random access, we have to go to the first location, check it is there or if the word is there or not. Second, we look at the second location and so on till we find the match. But in case of content addressable memory or associative memory, we search not based on the address, but based on the content. So how does this whole thing work? So first of all, let's say I want to search for a word. So the word that I want to search for, I will put it in the argument register. So suppose I want to search for a word XYZ. So I'll put the word in the argument register. Let us forget about the key register at the time being. Okay, we'll come to that later. So I want to search for the content XYZ. So somewhere in this associative memory, it may happen that the word XYZ is present. Okay, so in associative memory, what happens is that this content XYZ is searched parallelly in all the words of the memory array. And this particular register that we can see, that is the match register. So this register consists of M bits. this register consists of m bits. So 1 bit for one word of associative memory, because our associative memory consists of m words. So our match register also consists of m bits. So wherever we find that there is a match, let's say we may have one match, or we may have multiple matches, or we may not have any match at all. So let's assume that we have a match at position, this particular position, X, Y, Z is there. So what the search procedure will do is that it will make the corresponding bit of the match register to 1. So let's say that in the seventh word, for the seventh word, a match has been found. So the 7th bit in the match register will be set to 1, and all the others would be 0. So if we want to find out where, in which word we have found a match, then all we have to do is pass through the match register, and the points or the bits where we get a 1, the corresponding word in the associative memory will be your match. And if none of the bits of the match register has a 1, it means the word is not there in memory. And again, if I have multiple matches, then I will have multiple ones in my match register. So this is how basically the associative memory works. So we put the word to be searched in the argument register, and then the associative memory array consists of match logic, which will perform parallelly. It will match each and every word of associative memory. And if a match has been found, then the corresponding bit of the match register will be set to 1. So this is the basic block diagram. Again, like I said, I will come to the key register a little bit later. So now let us see what is there in each cell of our, how our associative memory and our argument and key registers, how the bits are going to be arranged. So let's say this is our associative memory. Okay, so here I have, this is my first word. This is the last word. So this is word number 1. And this is word number M. So each word, M words are there, and each word consists of N bits. So this will be my first bit. This will be my second bit. Like this. This will be my Nth bit. Okay, so let us call this C11. This as C22. Oh, sorry. This will be C12. C1, 2. That means word number 1, bit number 2. So the last one would be C1N. Word number 1, bit number N. Similarly, for word number M, I will have first bit, second bit, and so on, and then Nth bit. So I can call this CM1, CM2, CMN. So word number M, bit number 1, word number M, bit number 2, word number M, bit number N. So this is how the bits of this memory will be arranged. Now let us take into account the argument register. So this is the argument register. The argument register A will also be of length or size n bits, because here we are going to keep the word that we want to search. So each word is of size n bits. So our argument register will also be of n bits. So it will have n bits like this. Okay, so n bits here. Let's call this A1, bit number 1, bit number 2, and this would be AN. Okay, and coming to the match register will have 1 bit for every word in memory. So I will have 1 bit here, 1 bit here, and so on. So total, I will have M bits. So this, I will call it M1, M2, and this will be M small m, MM. Okay. And the same way, if we take the key register also will be of n bits. So the bits would be K1, K2 up to Kn. Now let us talk about the utility of the key register. Now, when I put something in the argument register, like here I had put XYZ as my argument that I want to search. Now, suppose I do not want to search the entire word. I want to search only say the first characters. All words starting with X, let's say. Okay. So in that case, XYZ would give me a match. Say XPZ would also give me a match because it starts with X. Okay. So how do I implement that? If I don't use a key register, if I just use the argument register and the memory, the match will, it will be just a exact match. If I say XYZ, it will search for only XYZ. But now I don't want an exact match. I want only part of it to be matched. So for that, we use the key register here, where we put a mask. We use a mask out here. And in this mask, what we do, we hide away those parts that I do not want to match. So for the ones which I do not want to match, I will put a 0. And for the parts which I want to match, I will put a 1. So I want that X is to be matched. It must start with X. So X in the position for X in the key register, I have a 1. I don't want to match Y and Z. So I have zeros here. Okay. So let me show this with another another example. Let's say I have A. In the A register, I have 101, 1111, 00. Then key register, I have 111, then 000000. Then I have word, and this is my associative memory. This is my first word. This is my second word. Word 1 and word 2. So word 1 is 100, 111100. Okay. And this is 101, 000001. So if we see now, if we see the match, then you can see here that in the key register, I have ones here. Okay. And this part is all zeros. That means from the argument register, I have to match only these 3 bits. Okay. So whatever may be in these remaining bits, where the corresponding bits in the key registers are 0, I do not have to do a match. So if you look at word number 1 and word number 2, you can see 101. This one is not a match because the first 3 bits are 100. But if you look at the last bits, they are the same. But what we are doing, because in the key register, the corresponding bits here are zeros. So we are not going to bother to look into what is here. We are going to match only what is here. That is the first 3 bits. Why? Because the key register has got ones in these positions. So here for the first word, it is 100, whereas my search is on 101. So this is not a match. Not match. Similarly, look at the second word. The second word, first 3 bits are 101, but the remaining bits are not matching with this part. So what we do, is it a match or not a match? This will be a match because our first 3 bits matches. Last remaining bits, we are not bothered because the key registers has got zeros corresponding to this. So this is a match. So that this is the utility of the key register. So we have the key register which performs this masking. Okay. So now, how do we organize the internal cells? That is, each of these cells of our associative memory, how are these constructed, or what are the things that they include? So each internal cell of your, say CIJ. CIJ would mean this is an internal cell of associative memory. Okay, which word? Word I, bit J. Ith word, jth bit. So what does it consist of? It consists of a flip-flop for the storage. For storage. So let us call it Fij is the name of the flip-flop. Okay. Then there are circuits for reading. For reading. Then there are circuits for writing. Okay. And then there is the match logic. There is the match logic. So these are the things which are there in each cell of your associative memory. So the input bit will be transferred to this cell. Okay, because it's a flip-flop, you can store it there, and that is going to happen in a write operation. And then when you are trying to read a cell, read the contents of a cell, then this bit will be given out as the output. And then when you're trying to search, okay, that is when your match logic comes into the picture. So how are you going to match the contents of the argument register with each and every content of your associative memory? So the match logic is basically, it is an algorithm for comparing the contents of the argument register with the contents that are there in your associative memory. In the next video, we are going to talk about the match logic and how these circuits are constructed.